Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Good evening. All right, let's begin. So this is the next chapter, similar triangles after coordinate geometry. I have a few more questions to share with you on coordinate geometry. I'm still to prepare them, which is why I've taken up the next chapter, similar triangles. So maybe if I finish them by tomorrow, tomorrow's class will be on coordinate geometry. We have seen distance formula and section formula, but we have a few more, not different variety, not different type of sums, but yeah, you need to know them. You will see it in the class tomorrow if the questions are ready. So this is the next chapter, similar triangles, and I'd also shared the playlist link with you. Tell me how many of you had time to watch the videos. Give out your names.
Ma'am, Bal Harish, ma'am.
Bal Harish, Shriya, Srinivasan,
Sudarshan.
Sudarshan,
Anish, ma'am.
Anish,
Harkavi, ma'am.
Kavi,
Muttuvel, ma'am.
Muttuvel. Okay. All right. So videos. See, I made those videos last year. During the pandemic when I did not, like start online classes on a platform like this. So those videos were made for students who are new to this classroom, that is have joined this year. The videos are mostly very crisp. It's fast in the sense it will not be for 15-20 minutes a video. I just make it, I keep going, I don't repeat anything in the video. I keep going, the entire content is delivered, and it depends, but maybe on an average less than 5 minutes. So you have to watch the video again. You cannot just watch it once and say, that it was too fast to follow. Yes, it is fast because I don't repeat. So you have to repeat watching the video because it becomes boring. No, if I make it for 15-20 minutes, then if you want to see it again, then you have to spend 20 minutes. So I thought I'll make it very crisp. So I don't repeat in the videos. I just keep going ahead so that if it's made for, 4 to 5 minutes, you can easily watch it again. Fine. That's what you should do. In case I share the videos, that's what you should be doing. Repeat watching the videos. So one video, you have to maybe watch it 2-3 times so that, it is registered, meaning you understand clearly. Okay. So this is the theorem which you have seen. This is the first one in the playlist. Okay, we are going to see the same thing again in today's class, children. I'm sure that it's not easy to remember this. So this revision will be really useful. If you have not watched, listen carefully. If you've already watched, it's a reinforcement. So anyways, it's going to help you. Yeah, so this is the theorem which you've seen in the videos. The basic proportionality theorem, or also called the Thales theorem. The statement goes like this. If a line is drawn parallel to any one side of the triangle to intersect the other two sides at distinct points, then the other two sides are divided in the same ratio. So how do we remember the statement? So see here, look at this triangle ABC. Look at this triangle ABC. Triangle ABC in which DE is parallel to BC. This line DE is drawn parallel to the side BC. Triangle ABC, triangle ABC. This line DE is drawn parallel to this side BC. AB, BC and AC are the three sides of the triangle. This line DE is drawn parallel to this side BC. And you can see that DE intersects the other two sides, AB and AC. The other two sides, AB and AC, are D and E respectively. Let's see it again. DE is drawn parallel to BC. That is, DE is drawn parallel to one side of the triangle. DE is drawn parallel to one side of the triangle. This is what is to be given to you. Now, if at all, you'll have to use this result, okay, in answering a question. What is to be given in order to use the result by basic proportionality theorem? What is to be given? You need to have a triangle in which you have a line parallel to one side of the triangle. You need to have a triangle, so triangle ABC, in which a line is parallel to one of its three sides. That's all. If you have this, then you can use the result by BPT. So here, triangle ABC, okay. DE is drawn parallel to BC, one side of the triangle, so BC. Now, if you have this, if this situation exists, then the result by BPT is AD by DB is equal to AE by EC. That is, the other two sides are divided in the same ratio. Which are the other two sides? DE is drawn parallel to BC. So the other two sides are AB and AC. The other two sides are AB and AC. The other two sides are divided proportionally. Proportionally meaning, okay, or in the same ratio, divided in the same ratio or divided proportionally, both mean the same. Divided proportionally or divided in the same ratio. So now when you have DE parallel to BC, you can see DE intersects AB at D and DE intersects AC at E. So this side AB is divided by this point D in the ratio AD by DB. And the other side AC is divided by this point E in the ratio AE by EC. Now these two ratios will be equal. The ratio AD by DB will be equal to the ratio AE by EC. Triangle ABC in which DE is parallel to BC. Given this, if DE is parallel to any one side, this line is drawn parallel to any one side of the triangle. So here in this figure, DE is parallel to BC. So the remaining two sides of the triangle are AB and AC. The ratio we have on AB is AD by DB. The ratio we have on AC, on the side AC, is AE by EC. Now these two ratios will be equal. So if a line is drawn, see, if this line is drawn parallel to one side of the triangle, if a line is drawn parallel to one side of the triangle, or if a line is drawn parallel to one side of the triangle to intersect the other two sides at distinct points. See, this line intersects the other two sides at distinct points D and E. If a line is drawn parallel to one side of the triangle to intersect the other two sides at distinct points, the distinct points are D and E. This line intersects the other two sides AB and AC at distinct points D and E. Then the other two sides are divided in the same ratio. The ratio here is AD by DB. The ratio here is AE by EC. The ratios are the same. The ratios are equal. We need to know the statement, children, though sometimes, okay, now it's going to be objective. Still, it's nice if you can, remember the statement. Let me just repeat it and then ask you. If a line, you have to visualize this to say. So if a line is drawn parallel to one side of the triangle to intersect the other two sides at distinct points, then the other two sides are divided in the same ratio. So given triangle ABC in which DE is parallel to BC, if this is given to you, given triangle ABC in which DE is parallel to BC, if this is given to you, a triangle and a set of parallel lines, if this is given to you, then the result that follows is AD by DB will be equal to AE by EC. That's the result. If you have a triangle in which DE is okay, if you have in this triangle ABC, if DE is parallel to BC, if this information is given to you, then the result is AD by DB is equal to AE by EC. Yes, try to memorize the statement. Slowly, read it slowly. If a line is drawn, and visualize that you're drawing, you have a triangle in your mind. See a triangle in your mind, and if a line is drawn parallel to one side of the triangle, and that line intersects the other two sides at distinct points, then the other two sides are divided in the same ratio. One of you look at the figure and try to say the statement. The statement of basic proportionality theorem. Yes, volunteer children.
Ma'am, if a
Yes.
line drawn is parallel to any one side of the triangle, side of the triangle,
to intersect
at two different points, then
to intersect
it
the
is
other
divided.
two sides. To intersect the other two sides.
To intersect the other two sides at distinct points, then it is divided in the same ratio.
Then the other two sides are divided in the same ratio. Good. Well tried, Arnav. Then the other two sides are divided in the same ratio. Yes. Somebody else try.
Ma'am, shall I try? Parkavi, ma'am.
Yes, Parkavi.
If a line is parallel to one side of the triangle, then the other two sides are intersect in distinct points, ma'am. And then the other two sides are divided in the same ratio.
Well tried, Parkavi. Let's do it again. Start like this. If a line is drawn, correct? I'll say a part of it. You say a part of it. So if a line is drawn, continue. If a line is drawn, what do you say?
Parallel to the one side of the triangle.
Okay. To intersect the, you continue.
To intersect the other two sides of the triangle in distinct points.
To intersect the other two sides at distinct points, then the other two sides are same in ratio. Divided same in ratio. Very good, very good. That's all, Parkavi. Very good. Yes. Anyone else wants to try? Yes, good. Arnav and Parkavi. One more student.
If a line drawn parallel to any one side of a triangle to intersect the other two sides at distinct point, the other two sides are divided in the same ratio.
Very good, Tirunesh. Very good. All right, children. So let's see the proof. So we are given a triangle. We are given a triangle. Here it's called ABC. We are given a triangle ABC in which DE is parallel to BC. This is given to you. A triangle ABC in which DE is parallel to BC, given to you. And you can see DE intersects AB, the other two sides. See, DE is parallel to BC. So this side is gone. The other two sides are AB and AC. You can see that DE intersects the other two sides, AB at D and AC at E. That's what you see here. So triangle ABC in which DE is parallel to BC, DE intersects AB in D and AC in, oh, sorry, by mistake, in E. This is E, children. By mistake, typing error, sorry. In E. DE intersects AB, AB in D and AC in E, children, EE. So the result that follows is, if you have this information, then the result is that this is what we'll have to prove. We'll have to prove that the other two sides are divided in the same ratio. That is, AD by DB is equal to AE by EC. Why AD we are saying? Because DE is the line. DE is the line. This line meets this side in D and this side in E. So you must, this is the point of division. This is the point of division. This is the point of division. So you must say AD DB by DB, AE by EC. Okay. So to prove this or to prove this result, we need to take up some construction. Join BE, join CD. That's one thing. Join BE, join CD. Draw EF perpendicular to AB. AB is a line segment AB. From this vertex E, you can draw only one line segment that's perpendicular to AB. Okay, from E you cannot draw many lines. From E you cannot draw many. See, this is an altitude basically. EF is an altitude on AB. That is, if you look at the triangle, if you look at this, if when you join, children, when you join BE, can you see this triangle AEB formed? When you join BE, can you see this triangle being formed? AEB, triangle AEB, triangle AEB, triangle AEB is formed. So you're dropping the altitude from this vertex E. You're dropping the altitude on the opposite side AB. There's only one altitude from E. There's only one altitude from E. So let EF, that's what is perpendicular. Draw EF perpendicular to AB. That means EF is an altitude from E on AB. See, children, when you join BE, we have a triangle AEB. We have a triangle AEB. So in this triangle AB, E is the vertex. E is one of the three vertices. EF is an altitude on the side AB of this triangle AEB. Similarly, when you join CD, you have a triangle ADC. You have a triangle ADC. See ADC. So from this vertex D, you drop a perpendicular on the opposite side. From the vertex D, you drop a perpendicular on the opposite side. That is AC. You drop a perpendicular on AC. So construction, join BE, join CD. Then from D, draw DG perpendicular to this side AC. From E, draw EF perpendicular to AB. This is the construction. Now we need to, you can remember, now we need to take up 4 different triangles and find their areas. We need to take up 4 different triangles and find their areas. So let me see if I've typed it correctly. So to prove that AD by DB is equal to AE by EC. So join BE and CD. Also draw DG perpendicular to AC and EF perpendicular to AB. Fine. Now we need to take up 4 different triangles, children. How do we remember? So look at this ratio. We have AD, right? AD. So ADE. Now you have this line D, right? The D is parallel to BC. In all the 4 triangles, you're going to take up, you must have DE. You must have DE. In all the 4 triangles you're going to take up. See, I said we are going to take up 4 triangles and find their areas. We're going to take up 4 triangles and find their areas. All right. In all the 4 triangles, you must have DE as a side. Remember that. You must have DE as a side. And see, in now the first triangle, we're going to take up ADE. Look at this AD. ADE. See AD. And it should have DE as a side. So ADE. I'll just try it once. And if you still don't understand, you can ask me. Look at this ratio. I'm sorry. Look at this proportion. Look at this proportion. We have AD, DB, AE, EC. I'm just taking help of this proportion to identify the triangles. So see, I have AD here, right? AD. And I also know that I should include DE as a side of all the 4 triangles. So now look at this AD. So AD, I should say ADE because I need to have D as a side. So ADE is one triangle. Let's say the first triangle. Then the next triangle. Look at this DB. The next triangle should be DBE because it should have DE as a side. DB, DB, DBE. DBE. So ADE. See this AD. AD. So ADE. And look at this one. DB, no? DB. DBE. It has DE as a side. So DBE. AD, DB, AD, DB, ADE, DBE. Then only it'll have this D as a side. And on the other side, AE. See here? AED. AED. I should have DE as a side. D as a side. AE. AED. And EC. So ECD. ECD. You can also remember like this is the point E here on this side. So when you're saying, when you're taking up triangles on this side, ADE. See here, this one, AD, ADE. And this one is DB. So DBE. On the other side, AE, AED. And this one is EC, ECD. Okay, I hope we understood the 4 triangles. Let's continue. I'll come back if you have any questions. Now, these are the 4 triangles. We are going to find the areas of these 4 triangles using the formula half base into height. Using the formula half base into height. So let's begin the proof like this. So the first triangle, area of triangle ADE. What is area of triangle ADE? Half base into height. Half base into height. So half into, you have the altitude on AD. So you have to take AD as the base because you have the altitude on AD. See, EF is perpendicular to this full side AB. So it will also be, so EF is also perpendicular to AD. EF is perpendicular to AB. It's also perpendicular to AD. So to find the area of this triangle, ADE, half base into height, half base AD into the corresponding altitude EF. Altitude, corresponding altitude is altitude that falls on that base. EF is the altitude on the side AD. EF is the altitude on the side AD. So if you take AD as the base, EF is the altitude. Half AD into EF. Similarly, the other triangle DBE, area of triangle DBE is half into. Now, if you see here, this one, now for this, now whenever you have a triangle like this, children, AEB, when you have a triangle like this, DE divides it into 2 smaller triangles. This is the whole triangle AEB. This is the whole triangle AEB. Now DE divides it into two smaller triangles. That they are ADE and DBE. This DE, this is the whole triangle AEB. This one. DE divides it into two smaller triangles. These two triangles, ADE and DBE. ADE and DBE. This is the whole triangle AED. AEB. This is the whole triangle AEB. AEB. This DE divides it into two smaller triangles. That's what we have taken up here. ADE, ADE, and this one, DBE, DBE. Now, the altitude of this triangle, the altitude for this triangle lies inside it. Now we know that EF is also the EF is the altitude, or EF is perpendicular to the side AB. And this for this triangle BDE, the altitude should, for if you take up BD as the base, the altitude should come from the opposite side, and it falls outside the triangle. That means this one is an obtuse triangle. When it's an obtuse triangle, the altitude will be outside the triangle. When it's an obtuse triangle, the altitude will lie outside the triangle. For triangle ADE, base is AD, altitude EF. So you see that here, half base into height. When you find the area of triangle DBE, you have to take up BD as the base, DB or BD as the base. Now, when you take up this one as the base, altitude should fall from the opposite vertex. The opposite vertex is E. From E, there can be only one line segment that's perpendicular to AB. You cannot draw from E, you cannot draw something perpendicular to DB like this. This is one line segment AB. From E, there can be only one line segment that's perpendicular to the full thing AB. From E, there can be only one line segment that is perpendicular to this full side AB. So whether you're looking for altitude on AD or DB, it should fall from the opposite vertex E, and that is EF. That is EF. So half base into height, half for this triangle, area of triangle DBE, half into base DB into the altitude. You're looking for the altitude from the opposite vertex. So opposite vertex is E. From E, this is the altitude EF. Half base into height, half DB into EF. Now divide these two areas. So when you divide one by the other, half gets cancelled, EF gets cancelled. So we have the ratio AD by DB. Next, find the area of triangle ADE. We already discussed the 4 triangles which we have to take up. So next, find the area of triangle AED, for which AE is the base and DG is the altitude. DG is the altitude on AE. So half AE into DG. Next, area of triangle ECD. So you're taking EC as the base, and the altitude will fall from D. The altitude on EC will fall from D, and that's DG. It lies outside the triangle. In the case of an obtuse triangle, the altitude will lie outside the triangle. So area of triangle ECD. If you take EC as the base, the altitude should fall from the opposite vertex D. ECD, the opposite vertex. The vertex opposite to EC is D. So you're looking for the altitude from D, that is DG. So the altitude actually lies on EC produced. It doesn't lie on EC. The altitude does not lie on EC. It lies on EC produced. For this one also, the altitude did not lie on BD. It lies on BD produced. So half base into height, half EC into DG. Now divide these two areas. Divide these two. Half gets cancelled, DG gets cancelled, and we have AE by EC. So we've got these two ratios. See, we got the ratios AD by DB, AE by EC. Now our task is to show that these two ratios are equal. We got a ratio AD by DB by finding the ratio of the areas of these two triangles. By finding the ratio of the areas of these two triangles, we got this ratio AD by DB. We got this ratio AD by DB. Again, by finding the ratio of the areas of these two triangles, we got this ratio AE by EC. AE by EC. We got this AE by EC. Now the task is to show that these two ratios are equal. Now the task is to show that these two ratios are equal, for which you have to show that these two ratios are equal. For which you need to show that these two ratios are equal. If you can prove that this ratio is equal to this ratio, it means this ratio is equal to this ratio. So let's prove that, or let's show that this ratio is equal to this ratio. These two ratios are equal. Now, when you compare the numerators ADE, ADE, they're the same. AED. See, triangle ABC, BAC, CAB is all the same triangle ABC. Okay, so you have AD here, triangle ADE, the same triangle AED, which is nothing but ADE. ADE, same triangle. So numerators are the same. Denominators, DBE, ECD. No, they are different triangles. But you have to show that these two triangles are equal in area, because this is all about area of the. This is all about the areas of the triangles. The numerators in this ratio and in this ratio, the numerators are the same triangles, or the numerators represent the same triangle. The denominator triangles are different. The denominator triangles are different. You need to show that their areas are equal. You need to show that area of DBE is the same as area of ECD. You need to show that area of this denominator triangle is the same as area of this denominator triangle. Now look at those two triangles here, DBE, DBE, okay, this one, and then ECD, 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 okay, this one. So it's about, see this children, it's about this triangle, this triangle, this triangle, and this triangle. I'll wait for some time, just have a look. DBE, DBE, this one, and ECD, 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 this one. Now from the names itself you can make out now which are the letters that are common. DBE, DBE, okay, so DE is common to both. You can see here DE is common. DE, see here also we have DE. That means both the triangles stand on the same base DE. See here those letters D, B, and E. Here in the denominator we have, see, we have D here, we have D here also. We have E here, we have E here also. The only other vertex different is B and C. Okay, so we have DE here, we have DE here also. That means both the triangles, they stand on the same base DE. The triangles are DEB, DEC. They stand on the same base. They stand on the same base. Now, how do we find the altitudes for the two triangles? Now, you know that these two triangles, they stand between the same parallels. We know that DE is parallel to BC. We know that DE is parallel to BC. We know that DE is parallel to BC. That's given to us. DE is parallel to BC is given to us. So clearly these two triangles, DEB and DEC, they lie between the two parallels. That means they'll have the same altitudes. Both the triangles will have the same altitudes. See here, understand one thing. The triangles, they have the same base. How will you say that they have the same area? If they have the same base and the same altitude, they'll have the same area. If two triangles have the same base and the same altitude, that is the numerical value. If the numerical values of the base and altitudes are the same, they'll have the same area. So now base is now both the triangles, they stand on the same base DE. So base we have sorted out. They have the same base. They have the same base DE. Now we are concerned about the altitudes. Altitudes, now since they lie between the same parallels, you know that the distance between two parallel lines is the same everywhere. So the perpendicular distance between the two parallel lines is the same everywhere. The perpendicular distance between the two parallel lines is the same everywhere. That means they have the same altitude. See here, because this is one triangle. This triangle lies between the two parallels. You can see the vertex B is on the other parallel line. And the vertex C lies on the other parallel line here. These two triangles, they have the same base DE and they lie between the same parallels DE and BC. What if they lie between the same parallels? If they lie between the same parallels, it means if they lie between the same parallels, it means that they have the same altitude. Both the triangles have the same altitude. That is the altitude on DE. The altitude on DE is the same. The length of the altitude. So on DE, the altitude will fall from B. And on DE, in the other triangle, the altitude will fall from C. They'll measure the same because these are two parallel lines. You can extend them. You can extend it like this. You can extend it like this. And you know that the distance, if you draw the perpendicular distance, this is the height. This will be the height. If you take DE as the base, the altitude should come from the opposite vertex C. This one is the height. And for the other triangle, if you take DE as the base, this is the altitude. This is the altitude. And the altitude is nothing but for the two triangles, the altitude is nothing but the distance between the two parallel lines. And that's the same everywhere. So last year, since this chapter was a part of the deleted portions, you do not know this theorem. So there is a theorem which says that when two triangles, they stand on the same base and between the same parallels, they are equal in area. There's a theorem which says that when two triangles stand on the same base and lie between the same parallels, they are equal in area. So here we have two triangles, DBE and ECD. They have the same base here, ED, DE. They have the same base DE. Both the triangles have the same base DE. And they lie between the two triangles, you can see DBE, DEC. They lie between the same parallels, DE and BC. Both the triangles lie between these two parallels, DE and BC. That means they have the same area. That means area of triangle DBE is equal to the area of triangle ECD. So the numerator triangles are the same. The denominator triangles are different, but they have the same area. So like if area of ADE, the numerator here says 10, 10, supposing. The denominator triangles are different, but they have the same area. So like if this is 30, this is a different triangle, but it has the same area 30. So you have 10 by 30 here, 10 by 30 here, 1 by 3, 1 by 3. So these two ratios are the same. Therefore, AD by DB is equal to AE by EC. So since these two ratios are equal, these two ratios AD by DB is equal to AE by EC. When two triangles stand on the same base and between the same parallels, they are equal in area. So when you consider the two triangles, you can read it here. They have the same base or common base. Parallels, they're located between these two parallels. So they're equal in area. They're equal in area. Triangles of the same base and between the same parallels are equal in area. So I've marked this one, result 1, this result 2, and this one 3. So from 1, 2, and 3, it follows that this one is equal to this one, or this one is equal to this one. From these results 1, 2, and 3, it follows that this is equal to this, which again means this is equal to this. Do not ignore the proof thinking that your term 1 is completely objective. See, last year we missed on a chapter areas of parallelograms and triangles where we have this theorem. So now this year, if that's what, see, now it's a carry forward. What you learn in the earlier standard, will somehow be, somewhere be applied in the next standard also. So do not ignore the proofs thinking that, it's going to be objective, it's of no use. Who knows, you might need all these results for your higher classes also. So do not ignore your portions, even if they're going to be objective in style. Your school may be conducting subjective exams. So this is the proof, children. Very simple. Just remember the way the proof goes. That's all. Remember the construction. So tell me what is to be given, children? In triangle ABC, what should be given?
A
In
side
triangle,
parallel to another
D
side.
parallel to B.
yeah, we should be, yeah. So by this figure, D is parallel to BC. That is enough. If this is given, if D is parallel to BC, then what is the result by BPT? If D is parallel to BC, then
AD by DB equal to AE by EC, ma'am.
EC. That's all. In a triangle, when in this triangle, since D is parallel to BC, that's all. If this is available in a triangle or in this triangle where D is parallel to BC, if this is given to you, the result is by BPT, AD by DB is equal to AE by EC. Okay. Any questions, children?
Ma'am, what were you saying? BPT? What theorem, ma'am?
This one, basic proportionality theorem, BPT. Okay. Yeah. Basic B, proportionality P, and theorem T. BPT or Thales theorem. Now tell me the triangles which you have to take up. You can see it here, but don't take help of this one. I'm not able to zoom in. Okay, tell me the triangles which you have to take up, children.
Triangle ADE. DE.
ADE,
Then a triangle BDE.
BBE. Then find this ratio, right? Find the ratio.
C.
We have to find the ratio of the areas of these two triangles, correct? Area of one
Yes,
triangle by the area of other triangle. Yeah, here on this side.
Then AED by ECD.
ECD, correct. Find the ratio of the areas of these triangles. The numerators will be the same. Denominator triangles, you must show that they are equal in area by using this theorem. And hence you get the result. Okay. So here in this figure, you're given this line DE is parallel to BC. In triangle ABC, DE is parallel to BC. So using the main result by BPT, you can get other results. We'll see what they are. So now you know when in a triangle. So here in this triangle ABC, we know that DE is parallel to BC. So by BPT, we have AD by DB is equal to AE by EC. Look at this here. This is given to us. We have a triangle and we have this line DE parallel to BC. It's given, see here. In the given triangle ABC, DE is parallel to BC. So that means AD by DB is equal to AE by EC. That means AD by DB is equal to AE by EC. Result by BPT. This result we get by BPT, basic proportionality theorem. Now add 1 to both the sides. To this result, this direct result by BPT, AD by DB is equal to AE by EC. Add 1 to both the sides. Add 1. So what you get? AD by DB plus 1 is equal to AE by EC plus 1. So LCM, you know, common denominator DB. So AD plus DB by DB is equal to AE plus EC by EC. What is AD plus DB? AD plus DB is AB. AB by DB is equal to what is AE plus EC, AC, AC by EC. So this is a new result. AB. So if you have this condition, if this condition is given, a triangle in which a line is parallel to one side, if this is given, we have another result like this. This is the direct result by BPT. We have another result like this. AB by DB. AB, see here, AB, this one, AB by DB is equal to AC by EC. The full side AB by DB is equal to this full side AC by EC. Isn't it rhyming? In the numerators, we have the full sides AB and AC. In the denominator, we have DB and EC. So to the result by BPT, if you add 1 on both the sides, you get a new result like this. AB by DB is equal to AC by EC. Now again, take up this result, whatever you got here. Take up this result. Now, oh sorry, I did not write it correctly here. All right, children, ignore it again. I've made them. Ignore this one. Ignore this one, children. It's a repetition. I did it today in a hurry, so I think, sorry. Just ignore this one. I don't know why I put this again here. Look at this one, children. Now this is the result by BPT. AD by DB is equal to AE by EC. This is the result. Take reciprocals on both the sides. Take reciprocals on both the sides. That is DB by. Take reciprocal of this one. See, one result we get by adding one. This is the actual result by BPT. This is the actual result by BPT. By adding 1 to both the sides, we get this new result. This is one thing. This is over. This is over. Now we're trying to get another one. For that, go back to the main result. Take reciprocals on both the sides. Ignore this one. Ignore this. Go back to the main result. Take reciprocals on both the sides. So you get DB by AD is equal to EC by AE. Reciprocal of this one. Okay. Now add 1 to both the sides. That is, first you take the result as it is, add 1 to both the sides, you get a new result. Then this main result, take reciprocals on both the sides. Please ignore this. Ignore this. Take reciprocals on both the sides. And then add 1. And then add 1. And then add 1. So DB by AD plus 1 is equal to EC by AE plus 1. So DB plus AD by AD is equal to EC plus AE by AE. So what is DB? What is DB plus AD? DB plus AD is AB by AD is equal to what is EC plus AE? EC plus AE is AC by AE. So this is another result, another new result. AB by AD, read this one. AB full side, AB by AD, the top part AD is equal to the full side AC by the top part AE, the top portion AD and AE. So now we have 4 results, children. We already have 4 results. One is the actual result by BPT, AD by DB is equal to AE by EC. This is the result by BPT. This is one. The other one is by taking reciprocals. So you get DB by AD is equal to EC by AE. Taking reciprocals, children. When you take reciprocals, you get DB by AD. That is writing this one first and then this one. DB by AD is equal to EC by AE. So this is the main result, and by taking reciprocals, you get this one. Now to this main result, when you add 1, what do you get? To this main result, when you add 1, you get AB, the full side AB by this down portion DB is equal to this full thing AC by this portion below EC. To the reciprocal, when you add 1, what do you get? The full side AB. So to the reciprocal, when you add 1, you get the full side. When you add 1, you get the full side AB by this one. This result is the top portion AD is equal to AC by AE. Now what we observe is when we added 1 to both the sides here, the denominators are not disturbed. That's what you'll have to note. See, this is important. Please look at the numerators are disturbed. The numerators become different. The denominators remain the same. When you see, this is a proportion. What is a proportion? When two ratios are equal, they are said to be in proportion. When A by B is equal to C by D, that means it's a proportion. A by B is equal to C by D is a proportion. Equality of two ratios is called a proportion. Okay, so in this proportion, in this ratio, this full thing is a proportion, children. This left hand side is a ratio. The right hand side is a ratio. This entire thing is a proportion. Okay, so to the left hand side, which is a ratio here, if you add 1, and to the right hand side, when you add 1, the denominator is not disturbed. You can see it below here. After adding 1 also, the denominator DB remains, the denominator EC remains. The numerator is disturbed. It becomes different. See here also, AD, AE. When you add 1, the denominator AD and AE remains AD and AE. The numerator is disturbed. It becomes AB and AC. It becomes a full side AB and AC. Children, excuse me. I'm just coming back. Thank you, children. Yeah, so I was telling you that I lose my chain of thoughts if I'm disturbed like this. I was telling you that when you add 1 to both the sides, the denominators are not disturbed. The numerators are disturbed. They become different. The denominators remain the same. Now the reciprocals of these two will further give you two more proportions. Take the reciprocal of this dB by AB. Take the reciprocal of this one. So see, these are the 6 different results we have. This is the result by BPT. When you add 1 to both the sides, this is the new result. Okay, so we have 1, 2. Now this is the reciprocal of the result by BPT. This is the reciprocal. This is the reciprocal of this result by BPT. Okay. Now, so this is the third one. 1, 2, this is 3. Reciprocal is 3. Now to this reciprocal, if you add 1 to both the sides, you get another new proportion. 4. When you take reciprocal of this 5, when you take reciprocal of this 6. So reciprocal of this one, dB by AB, dB by the full thing AB is equal to EC by the full thing AC. And similarly, the reciprocal of this one, AD by AB, AD by the full thing AB is equal to AC by AE. Oh, sorry, I missed it. The reciprocal of this one, AD by AB. So AD by AB. The reciprocal of this one, AE by AC. So these are the 6 results. Now that you know, see, if you have to prove that AB by DB is equal to AC by EC, then you'll have to show this procedure. When you're working proofs, you can directly use these results. You don't have, if you have to prove this, then you'll have to show this working. If given this information, if you have to prove this one, then you need to show these steps. Otherwise, different proof. You can use these results directly. You don't have to show this working. You can directly write this result and say by BPT. You can directly write this result and say by BPT. In fact, you can write all these 6 results and say by BPT. What we just discussed, I put all of them together here. I'm sorry, children, I'm disturbed a lot today. Now tell me all the 6 results now. What is the result by BPT? The direct result by BPT? What is the direct result by BPT?
AD by DB is equal to AE by EC.
What is the reciprocal of this one?
DB by DA is equal to EC by EA.
Correct. Okay. Now tell me one more proportion. Anyone? Something else? Take the full side and tell me. Take the full side and the top portions. Class. Take the full side and the top portions alone.
Ma'am, AB by AD is equal to AC by AE.
AE, correct. AB by AD is equal to AC by AE. Now, what's the reciprocal of this?
AD by AB equal to AE by AC.
Very good. Now we took the full sides and the top portions, right? Now take the full sides and the bottom portions.
AB by DB equal to AC by EC.
Reciprocal?
DB by AB equal to EC by AC.
That's it. Very good. Thank you, Parkavi. Thank you, Tirunesh. I think Arna. Okay. Thanks, children. So that's it. These are the 6 results by BPT. If you have to prove one of these, you have to show the steps. Otherwise, you can write, you write any one of these 6 results, you can just say by BPT. So first take the portions above and below. So this is the direct result. AD by DB is equal to AE by EC is the direct result. Reciprocal of this one will be DB by AD is equal to EC by AE. This is the reciprocal. So two proportions done. Now the third one, take the full sides and the top portions. So AB by AD is equal to AC by AE. Reciprocal of this will be the fourth one. That is AD by AB is equal to AE by AC. The other one will be take the bottom portions and the full sides. So AB, the full side AB by this bottom portion DB is equal to the full side AC by this portion EC. And the reciprocal of this DB by AB is equal to EC by AC. So these are the 6 different results we have by BPT. You can take a screenshot, children. This alone, make it E. Take a screenshot. Okay. The proof for the converse of BPT we'll see in the next class. It might become too much. We'll take up the exercise and example problems. So we'll see this proof tomorrow. I'll just tell you what the statement is. So converse of BPT or the converse of Thales theorem, converse of basic proportionality theorem, it's just the other way. The information given the other way around. So there, given parallel lines, the proportion is true. See, this is how we easily say this. Given parallel lines, a proportion is true. Given D is parallel to BC, okay, of course we should have a triangle, not a quadrilateral. So given in a triangle, okay, so let's just take that for granted. We have a triangle. So if we have a set of parallel lines like this, then this proportion is true. The converse is, given this proportion in a triangle, these lines will be parallel. Given this proportion, So if a line divides any two sides of the triangle proportionally, then that line is parallel to the third side. Given the proportion, this parallel lines, given the proportion, two lines will be parallel. That is, the one line will be parallel to the third side of the triangle. The other way around, the information the other way around. Parallel lines given, then the proportion is true. If proportion is given, parallel lines true. If a line divides any two sides of the triangle proportionally, then that line must be parallel to the third side. If a line divides any two sides of the triangle proportionally, that is, divides it like AD by DB is equal to AE by EC. If a line divides any two sides of the triangle proportionally, that means this proportion is given, then that line should be parallel to the third side. That line should be parallel to the third side. Is the statement of converse of BPT. Converse of BPT. Statement of converse of BPT. We'll see the proof tomorrow. Okay, in the same ratio, meaning proportionally. If a line divides any two sides of a triangle in the same ratio, that is proportionally, then the line must be parallel to the third side. So this is example 1 in NCERT. So see this, children, if a line intersects sides AB and AC of a triangle ABC at D and E respectively and is parallel to BC. DE is parallel to BC. So enough, we have a triangle, DE is parallel to BC. We need to prove that AD by AB is equal to AE by AC. Okay, what's the result by BPT? Now that DE is parallel to BC, what's the result by BPT, children?
AD by DB is equal to AE by EC.
Yeah, so because in the triangle DE is parallel to BC, by BPT we have AD by DB is equal to AE by EC. Now this one is AD by AB. So whenever you're getting the full side, AB and AC, it is got by adding 1. See the denominators, AB and AC. When you have the full sides AB and AC, to this result by BPT, we need to add 1. But the thing that should come to your mind is, should I add 1 as it is, or should I take reciprocal and then add 1? So you should identify the segments that are in this proportion. You will get AB and AC by adding 1. But you can see here AD and AE, you must have AD and AE. So that means in the proportion which you have, you must take AD and AE to the denominator. Because I told you, whatever is in the denominator is not disturbed after adding 1. Numerators change, denominators don't change. You want to have AD and AE. See here, AB and AC, the full sides, you will get when you add 1. Okay, so don't worry about AB and AC. You must worry about AD and AE. You need to get in the result after adding 1, you should get AD and AE. That means you must take them to the denominator. Only then they'll not be disturbed. So you must take the reciprocals and then add 1. You must take the reciprocals and then add 1. So see here. This is given to you. So this is the direct, see here, children. This is the direct result by BPT. Read this, AD by DB is equal to AE by EC. Why are we taking reciprocals? Because in the result here, we have, see here, ADAE, ADAE, ABAC, this is DBEC. They don't want DB and EC. They don't want. If you don't want them, take them to the numerator. If you want them, have it in the denominator. What you want, have it in the denominator. What you don't want, take it to the numerator. So you don't want the final result, you don't want dB and EC. So take them to the numerator. So automatically this will come down to the denominator, what you need. No, only if you tell me if you understand, because the rest of it is easy. Adding one and getting the result, you know. So this is the result by BPT. Sometimes you have to add one straight away. Sometimes you need to take reciprocals and then add one. So here we have to take the reciprocal and then add one because we have AD and AE in the result here. So you need AD and AE are in the numerators. When you add one, you lose them. You will not lose the denominators, you will lose the numerators. But you don't want to lose them because you want AD and AE in the result. So take reciprocals. When you take reciprocals on both the sides, you get AD and AE in the denominator. So even if you add one, you will not lose them. They still remain AD and AE. So that when you add one, you get AB by AD is equal to AB by AD is equal to AC by AE. Take reciprocals again to get this result. Look at this. Children, if you have any questions, ask me. Shall we take up the next one, children?
Yes, ma'am.
Yes, ma'am.
Okay. Others?
Yes, ma'am.
All right. So here, an example 2. We have a trapezium ABCD with AB parallel to DC. E and F are points on the non-parallel sides AD and BC respectively. AB and CD, these two are the parallel sides. These two are the parallel sides. So these two, AD and BC, are the non-parallel sides. E is a point on AD, F is a point on BC. Such that EF is parallel to AB. EF is parallel to AB. EF is parallel to AB. We need to show that, given all this, we need to show that AE by ED is equal to BF by FC. So trapezium, this side parallel to this side, these two sides are non-parallel. E is a point on AD, F is a point on any point, not the midpoint, any point. E and F are not given to be the midpoints. They are any, E is any point on AD, F is any point on BC. EF is parallel to AB. Given this, we need to show that AE by ED is equal to BF by FC. So in order to use BPT and get the C, we have a proportion. We need to prove a proportion. So to get a proportion, BPT will help you. In BPT, if you have a triangle with parallel lines, then you can get a proportion. You can get a result which is a proportion. So we'll join the diagonal AC. You can also join the diagonal BD. I think in the video I have connected the diagonal BD. Let me say diagonal AC here because that's how I worked it here. You can connect anyone. You can connect the diagonal AC or you can connect the diagonal BD, any one of the two. So any one of the two. So here I've connected the diagonal AC. So join AC. Join AC. Why should you join AC? Because it's a quadrilateral. We need to have triangles in order to use BPT. We need to have triangles. So we'll divide the quadrilateral trapezium into two triangles by connecting the diagonal AC. So join AC. As you join AC, you know AC, when you join AC, AC will intersect EF. Let's say it intersects EF at G. When you join, when you draw a line like this, you know, you'll have to go through, you'll have to pass, you'll have to cut EF. So let it cut EF at G. Okay, let AC cut EF at G. Now we have two triangles. Now we have two triangles. Now we have to identify the parallel lines. You have to see, it's very simple. Identify triangles which have parallel lines in accordance with BPT. Okay, identify triangles with parallel lines to suit the theorem and write the result. So you should take two triangles. You should take take one triangle. State the lines which are parallel. Write the proportion by BPT. Take the other triangle. State the parallel lines. Write the proportion by BPT. By comparing these two proportions, like if A by B is equal to C by D, and if A by B is equal to E by F, if A by B is equal to C by D, and A by B is equal to E by F, from these two proportions, what follows? What follows? Don't ask me to repeat it. I was already slow. What follows from these two proportions? Class, what is this? Don't make me feel awkward, please. Is my voice reaching you clearly? Why the silence all of a sudden? Let's not waste time. Come on. Tell me something. Okay, am I audible or not?
Yes, ma'am.
Yes, ma'am.
Okay, I was saying, yeah, if A by B is equal to C by D and A by B is equal to E by F, from these two proportions, the new result is C by D is equal to E by F. Okay, if 1 by 2 is equal to 3 by 4, and if 1 by 2 is equal to 5 by 6, 1 by 2 is equal to 3 by 4, 1 by 2 is equal to 5 by 6. That means 3 by 4 is equal to 5 by 6. That's all. That's how you prove this proportion. Join AC, take two triangles, write the results by BPT. That is, you will be writing two proportions, two different proportions. On comparing the two proportions, you will get this result. So let's see that. Now tell me, which triangles to take? Again, here there are only two triangles, but which triangles to consider? Triangles where you have parallel lines in accordance with BPT. Okay, so supposing we take the triangle ABC. Supposing we take the triangle ABC. Supposing we take the triangle ABC. Tell me, what is parallel to what? Now, this is important. Look at this one here. Please understand this yourself. See this and understand this yourself. Two lines parallel to the same line are parallel to each other. That's what it is. DC and DF. DC and EF are two lines which are parallel to the same line AB. So they are parallel to each other. DC is parallel to EF. DC and EF are two lines that are parallel to the same line AB. So they are parallel by the result is the two lines are parallel to each other. EF is parallel to DC. AB is parallel to CD because it's a trapezium. It's given that these two sides are parallel. EF is parallel to AB is also given. EF is parallel to AB is also given. These two are given to us. So from these two, we have this new result. EF is parallel to DC. That is EF is parallel to DC. That is all the three lines are parallel to one another. The three lines are parallel to each other. That's the result. Now when you take up the triangle ABC, tell me the parallel lines. Children, if you participate, it will be, I can convince myself that, you've understood. Please participate. Tell me in triangle ABC.
AB parallel to FG, ma'am.
AB is parallel to FG. Why? Because AB is parallel to?
Because AB is parallel to EF.
EF. Because AB is parallel to EF. GF is a part of EF. GF is a part of EF. So AB will be parallel to GF. AB is parallel to GF. Because AB is parallel to EF. So AB will be parallel to GF, which is the triangle ABC. In triangle ABC, Parkavi, GF is parallel to AB, correct?
Yes, ma'am.
Yeah, GF. This line GF or this line segment GF is parallel to this side of the triangle AB. So what's the result? By BPT?
By BPT, AG by GC equal to
BF by
FC.
FC. See, this is the line GF. If you start like AG by GC, you must not say CF. You're taking these portions first and then see this is GF. These are below GF and whatever. These two pieces are on one side of GF. These two pieces are on the other side of GF. So if you say AG by GC is equal to, you should start from here, BF by FC. These two pieces are on one side. These two are on the other side. So if you say AG by GC, you said AG, right? Now you must say BF by FC. Which is the other triangle? Not Parkavi again. Thank you, Parkavi. Which is the other triangle which you can take up and apply BPT?
Ma'am, BCD.
BCD. Where is the triangle BCD?
BCD, ma'am. Ma'am, BCD.
How BCD?
Ma'am, ADC.
ADC. ADC. Who's this?
Arnav.
Arnav. Yeah, Arnav. Yes. ADC. In triangle ADC, which are the lines parallel?
EG is parallel to DC.
EG is parallel to DC, but it's not given EG is parallel to DC. How do you conclude that EG is parallel to DC?
BPT, ma'am.
No, please. How? My question is, how do you say that EG is parallel to DC?
Ma'am, AE by ED is equal to AG by GC.
No, 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 no.
Ma'am, because EG is the part of EF, ma'am.
Parkavi, yes. Well, thank you, Parkavi, but let me just ask somebody else. Children, my question is, Arnav says in triangle ADC, EG is parallel to DC. Why? Why is EG parallel to DC? How can we say that EG is parallel to DC?
Ma'am, because AB is parallel to EF and AB is parallel to DC, ma'am.
Because AB is parallel to
EF and also parallel to AB and CD, ma'am.
no. That's not the relevant answer. No.
Ma'am, once again, can you show the question what's given?
Yeah.
Ma'am, because on trapezium, this AB and DC are parallel.
Okay.
So then, and also it's given that EF is parallel to AB.
Okay.
So you said now that two lines parallel to the same line is parallel to each other.
Very good. Yes.
So AB is parallel to DC. I mean,
Yeah.
EF is parallel to DC.
Correct. Correct. So EF is parallel to DC. Fine. So
And we know that if a part of it, if a part of a line is parallel to the other line, then they are parallel.
yeah, correct. That's what I wanted. You're right, Arnav. So since EF is parallel to DC, a part of EF will also be parallel to DC. It's not about equality, children. Equal you cannot say. If EF, supposing EF is equal to DC, a part of EF cannot be equal to DC. No. We are not talking about, we are not dealing with equality. Parallel. These two lines are parallel. So any part of this line will be parallel to the other line. So since EF is parallel to DC, EG also, EG is a part of EF, will be parallel to DC. So Arnav, this is known to us. In triangle ADC, EG is parallel to the side DC of the triangle, correct?
Yes, ma'am.
Now what is the result by BPT? This we must have. Now what's the result by BPT?
AE by D is equal to AG by GC.
Yeah, because EG is parallel to DC. The points are E and G. You must break up these points. AE by ED is equal to AG by GC. If you start from AE by ED, you must say AG by GC. If you say DE by EA, then you must say CG by GA. That's it. Write these two proportions, compare and get the result. Yes, have a look, children. Have a look at the answer for the proof. So supposing you had written this one as supposing here or say here in ABC, if you had written CG by AG, is equal to CF by FP. You can take reciprocals on both the sides. See, now in these two proportions, we have AG by GC, we have AG by GC. So this is common in both the proportions. AG by GC, AG by GC. This ratio is common. So AE by ED is equal to BF by FC. AE by ED is equal to BF by FC. Because in these two proportions, we have a common ratio, AG by GC. So these two are equal. Now I'm saying if supposing you had written this or any one of them as a reciprocal, supposing you had written this as GC by AG is equal to FC by BF, then you wouldn't find a common ratio. Then just invert it. Just take reciprocals. Take the reciprocal of this or this. Then you will find a common ratio. If a ratio is inverted, take reciprocals on both the sides. Then you will find a common ratio and you can equate the other two ratios. So since this is common, these two ratios are equal. So these two parallel lines given, this is the result. Two lines parallel to the same line are parallel to each other. So after identifying all the parallel lines, take up one triangle where this set of lines are parallel. This is the result by B. This should be given to us, or we must know this. In a triangle, when you have a set of parallel lines like this, if a line is parallel to one side of the triangle, then this proportion is true by BPT. Another triangle, set of parallel lines. This one is parallel to the side AB of the triangle ABC. Then, since you have this, the result by BPT is this proportion. Now compare these two proportions from 1 and 2. Comparing these two proportions, we have the result, which is to be proved. All right. Children, are you confident? If you probably revise it once again, are you sure of the proofs? Will you be sure of the proofs? Today you plan to, yeah, you by keeping silent, you're embarrassing me. Say something, whether yes or no. The answer need not be a yes or any one of the two. Yes or a no. Please answer. Are we following, children?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. See, we've come past these two examples. If you have any questions, ask me now, because as we get into the chapter, then and you have a doubt with the BPT, you don't know how to apply BPT, then it becomes difficult. So maybe tomorrow go through before you take up tomorrow's class, revise BPT, converse of BPT, those six. Oh, converse of BPT we did not do today. Okay, revise the statement, BPT statement, the proof for this theorem, and the 6 results which we get, one main result and the 5 other results. One main result by BPT and 5 other results. So in all we have 6. And then go through example 1, example 2, and now we're going to do example 3. Complete, revise all that we finish in today's class. So tomorrow, if you have any questions based on this, get it clarified tomorrow itself, children. If you hold it up, it's going to become a difficult chapter for you. Numerical ones, you can work something at least. When it's a proof, you don't know what to do with it. Numerical ones, you can just write some form, do something, you can try. proofs are difficult. You cannot just write anything.
Okay.
Yeah. So in example 3, in this figure, triangle PQR, we have a proportion. That means when a proportion is given, you must use the converse of BPT. When parallel lines are given, you should use BPT. See, for BPT, in a triangle, when you have parallel lines, by BPT, we get the proportion. Converse of BPT, in a triangle, when some proportion is true, then we identify the parallel lines. BPT, given parallel lines, a proportion is true. Converse of BPT, given a proportion, parallel lines, you identify a set of parallel lines. So in this figure, we have this proportion which is true. PS by SQ is equal to PT by TR. It's given. Angle PST is equal to angle PRQ. That's marked there. You can see. So this proportion is true. PS by SQ is equal to PT by TR. So children, in triangle PQR, if this proportion is true, what will you conclude?
Then the line is parallel to the third side, ma'am.
Which line?
The line which is divides
in this figure, which line is parallel?
ST is parallel to QR, ma'am.
ST is parallel to
QR.
QR. Very good. ST is parallel to QR. Because see, these are the points. PS, SQ. PS, SQ. So S is the point on the side. And PT, TR. PT, TR. T is the point on the side. S and T are the points. So ST is parallel to QR, the third side QR. In triangle PQR, this proportion is true. PS by SQ is equal to PT by TR. So in this triangle, this result is true. PS by SQ is equal to PT by TR. This is true. Then that means two lines are parallel. Which are the two lines? You can make out from this. S is common. S is common here. T is common here. So S and T are the points. The join of S and T, ST, ST. Now these segments are on which side? PSSQ. PSSQ on the side PQ. So leave that side. PT and TR. PT and TR. They are segments on PR. Leave that. So this is the third side QR. So this is parallel to the third side QR. QR is the third side because these segments, see here, PS and SQ. PS, SQ are on the side PQ. So leave that side. The segment, these segments PT and TR. PT and TR are on the side PR. So leave that side also. So ignore these two sides. That means the third side. Or in other words, this is the first side, this is the second side. Or this is the first side, this is the second side. So this is the third side. QR is the third side. And how do you make out ST? You can see that common. PSSQ. PSSQ. So S. PT, TR. So T. So ST is parallel to the third side QR. So if this proportion is given by converse of BPT, ST is parallel to QR. ST is parallel to QR. Now children, if I number this 1, okay, I call this 1. All you see here, I call this 1. I call this 2. I call this 2. Is 1 equal to 2? You must say yes because it's given. Because PST is equal to PRQ. So if I call this 1 and this one as 2, 1 is equal to 2. But now ST is parallel to QR. ST is parallel to QR. So if I mark this angle as 3, if I mark this angle as 3, Angle 1 is equal to angle 3. Corresponding angles are equal. Because by converse of BPT, ST is parallel to QR. By converse of BPT, ST is parallel to QR. So if I mark this angle as 3, angle 1 is equal to angle 3. Angle 1 is equal to angle 3. Corresponding angles are equal. But angle 1 is equal to angle 2 given. 1 is equal to 2 given. 1 is equal to 2, 3 corresponding angles. So that means 2 is equal to 3. If 2 is equal to 3, if angle Q is equal to angle R, it means PQ is equal to PR. When two angles are equal, the sides opposite to them are also equal. So PQ is equal to PR, and hence PQR is an isosceles triangle. Please go through the proof. Come from the question given, what is given, what is to be proved. Read everything carefully. In a triangle, when two sides are equal, when two angles are equal, the sides opposite to them are also equal. See, when you're trying to understand this, you should ignore this line ST. Ignore this line ST. Angle 2 is equal to angle 3, which is the side opposite to angle 2. Don't see this line. Just erase this. Erase this. So see only this triangle PQR. PQR. So opposite to angle 2 is PQ. Opposite to angle 3 is the side opposite to angle 3 is PR. So if 2 is equal to 3, the side opposite to 2, PQ, is equal to the side opposite to 3, PR. PQ is equal to PR. So when two sides are equal, the triangle is an isosceles triangle. Very simple proof. Very simple. 1 is equal to 2 is given. So we just have to prove that 1 is equal to 3. 1 is equal to 3. 1 can be equal to 3 only if ST is parallel to QR, because then 1 and 3 will be 1 and 3 by position, they are corresponding angles. They'll be equal when ST is parallel to QR. 1 and 3 already are corresponding angles. By the position, they are corresponding angles. They'll be equal if ST is parallel to QR. And ST is parallel to QR by converse of BPT. So ST is parallel to QR by converse of BPT. That means angle 1 is equal to angle 3. Corresponding angles are equal. But 1 is equal to 2 given. So comparing these two, we have 2 is equal to 3. 2 is equal to 3. Angle 2 is equal to angle 3. So that means the sides opposite them will also be equal, which means a triangle is an isosceles triangle. Right. So these are some numerical applications of BPT. So children, you can see here in figure 1 and 2. In figure 1 and figure 2, D is parallel to BC. DE is parallel to BC. DE is parallel to BC. DE is parallel to BC in both the figures. Okay. You must find EC in the first figure. You must find EC in the first figure and AD in the second figure. AD, where is AD? AD in the second figure. So how will you do it, children? How to work this?
For first figure, we can do by BPT. 1.5
Yeah.
by 3 is equal to 1 by EC. Then we transpose it to the opposite side. Then
Correct.
it becomes 2 centimeters.
Very good. The next one?
Next one also same only.
Yeah. Because DE is parallel to BC, by BPT we have AD by DB equal to AE by EC. So just write the proportion. Yeah. Write the proportion, substitute the values. Yeah, 2.4. Write the proportion, substitute the values and calculate. Take a screenshot. This you can help yourself, children. Take a screenshot. Let's just do the third one. We'll just do the third one. See the question here. E and F are points on the sides PQ and PR, respectively, of triangle PQR. For each of the following, so something like this. So triangle PQR, E and F, like this. So triangle PQR, E and F are 2 points on the sides PQ and PR, respectively, of triangle PQR. So in each of the following cases, you should state if EF is parallel to QR. If you join EF, okay, for these values, you must check if EF can be parallel to QR. EF and QR can be parallel to each other. EF and QR. Okay. So if you have to check if lines are parallel, you should use the converse of BPT. If the proportion is true, then the lines are parallel. If the proportion is true, then the lines are parallel. So see the third one. See the third one. You must find the ratio PE by EQ. Then find the ratio PF by FR. If these two are equal, then EF is parallel to QR. You must find the ratio PE by EQ. Then find the ratio PF by FR. If these two are equal, then the lines are parallel. So see the values given. We have PQ is 1.28. PQ is this full thing. PQ is a full thing. PR is given, full thing. PE is given and PF is given. But you need to use a direct result, children. PE by EQ. Okay. You need to use PE by EQ and PF by FR. So how do you find P by EQ? P is given straight away. EQ is PQ minus PE. Go through this. I'm just coming back. Go through this, children. So children, we have to find P by EQ, this ratio. We are finding, you should not write P by EQ is equal to PF by FR. You cannot write that. That you can write only if EF is, if you're given EF is parallel to QR. If it's given EF is parallel to QR, yeah, then you can write PE by EQ is equal to PF by FR. Here we have to prove that EF is parallel to, meaning we'll have to check if EF is parallel to QR. So you're finding the ratio separately. You should find P by EQ. Then you must find PF by FR. Check if these two are equal. If they're equal, they're parallel. The lines are parallel. Otherwise, not. So P by EQ. P is given. EQ is not given, but EQ is PQ minus PE. Similarly, FR is not given. FR is not given. It's PR minus PF. Okay. So it so happens that P by EQ is 9 by 55. PF by FR is also 9 by 55. So from these two, P by EQ is equal to PF by FR. So by the converse of BPT, that is these ratios are equal. P by EQ is equal to PF by FR. See, we've got 9 by 55 for both. So by the converse of BPT, EF, when you join EF will be parallel to QR. EF is parallel to QR. Class, use the emoji. Raise your hand. Priyadarshini, Hariharan, Sudarshan, Shriya, Akshayram, Nafi, Ashwin, Srinivasan, Lakshita, Shivani, Nivedita, Muttuvel, Priya, Reshmi, Rakshan, Harshita, Tirunesh, Arnav, Parkavi. This class has about 28 students, 26 or 28 students, but I don't see the full strength any day. Because I shared the recording, it's convenient if you just want to, if you have some other work, you just opt to miss the class, maybe you can use a recording. Okay, but one thing that I feel very happy about is that all of you are at your desk. The moment I say use the emoji, raise your hand, I can see all of us actually always promptly using the emoji. Thank you so much for that, children. So let me just tell you how this proof goes. I'll not tell you in detail. I'll just tell you how to go about this proof. So see, children, whenever you have to prove a proportion like this, we have two sets of parallel lines. Where can this be applied? LM parallel to BC can be applied in triangle ABC. See here, LM is parallel to BC. LM is parallel to BC. LM is parallel to BC. This one can be applied in this triangle ABC. ABC can be applied in the triangle ABC. Then, so in this triangle ABC, when these two lines are parallel, you can write the result by BPT. AM by MB is equal to AL by LC. Next, where can we use this this information which is given LN parallel to CD in triangle
ADC.
ADC, in triangle ADC. In triangle ADC, you can use this information. LN is parallel to CD. So again, by BPT, what do we have by BPT? If LN is parallel to CD, then in this triangle, what is the proportion?
CL by AL is equal to DN by AN.
Or AL by
LC is equal to AN by ND.
Very good. Okay. So now we have two proportions, right? When you compare, you will get one new proportion. See here, you have two proportions. You have this proportion from one triangle and this proportion from the other triangle. When you compare both AL by LC, this is common. So we have a new proportion. AM by MB is equal to AN by ND. AM by MB is equal to AN by ND. So in this triangle, we have these two lines parallel. So this is the result by BPT. Again, in this triangle, these lines are parallel. So this is the result by BPT. When you compare these two proportions, we get a new result. AM by MB is equal to AN by ND. But this is not the required result. We have to prove something else. Compare what you have got and what is to be proved. Compare what you have here and what is to be proved. Compare both. What do you see? AM by MB. AM by AB, AN by ND, AN by AD. Okay, so that means we need AM and AN. We need AM and AN in the results here, AM and AN. We don't want MB and ND. What you want, have them in the denominator. So you want, see here, the final result, this result has AM and AN. AM and AN, they are the numerator. Bring them to the denominator. So take reciprocals. This property of proportions is called invertendo. Taking reciprocals on both the sides is called invertendo. Invertendo meaning when you're dealing with proportions, when you say invertendo, you take the reciprocals on both the sides. Okay, so MB by AM is equal to ND by AN. Now see what you want to have, no? You want AM and AN. See, AM and AN are in the numerator here. Don't worry about that. That will bring them to the numerator later. I'm saying when you compare this and this, when you compare these two, you can see that AM and AN, you need this one in the final result. You want to have this in the final result. So have them in the denominator, only then they are not disturbed. Bring AM to the denominator, AN to the denominator. Then add 1 to both the sides. So take reciprocals and then add 1 to both the sides. So even after adding 1, what happens here? The numerators, they change. Always to a proportion when you add 1 to both the sides. Whatever you have in the denominator will remain. the numerator will change. The numerator will change. You want to have am and an, so have them in the denominator. So take reciprocals on both the sides and then add 1. Then you get a result like this. But you need this, so take reciprocals again. You got AB by AM is equal to AD by AN. Take reciprocals on both the sides or invertendo, applying the property of invertendo. AM by AB is equal to AM by AD. Okay, children, so that's it for today's session. Take a screenshot. Please go through all these by tomorrow's class so that you can get your doubts clarified and feel comfortable for the rest of the sums. Yes, children, thank you so much. If you have questions to ask today, you can stay back, else you may leave the call. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank
Thank you,
you.
ma'am.
Thank you, children.